So this is part 2 of our exploration of extinction. It's going to be a bit of review as I tie together some concepts that we've covered earlier in the class, but put them in a new context now that we have a greater appreciation of where species come from and their importance. So I want to remind you about the idea, the concept of ecosystem services or ecological services. These are the things that ecosystems do for us for free. Life as we know it could not exist without ecosystem services. Every time you take a breath, you're using oxygen that was created by plants, most of that being actually algae out in the oceans, phytoplankton out floating on the oceans, creating the majority of the oxygen that's in our atmosphere, but of course also our trees and other plants on the land as well. Oops, sorry about that. And we learned earlier this semester that there are 4 different categories of ecosystem services, and you see those in this pie chart here. Let's take a look at those real quick as a reminder. First, there are provisioning services. So this is when we actually take things from nature. It might be wood, it might be animals to eat, or it could be plants for fiber, or when we're taking water from the environment for drinking. Anytime that nature or ecosystems are providing things to us, we call it a provisioning service. Another type of service that's very important is, of course, regulation services or regulatory services. That's basically ecosystem processes that are moderating natural phenomena out in the environment. So think of floods. If it wasn't for wetlands and floodplains, we would have way worse flooding in our creeks and streams and rivers. Ecosystems along the coast that protect against storm surges and tsunamis. Pollination, I think we already talked about that 75% of the plant species that humanity cultivates and depends on animals for the pollination of those plants. So these are just some examples of these processes that ecosystems provide, and we call those regulatory services. Very important for sustaining humanity. Cultural services, this would be where you have things that we don't necessarily need are provided to us by nature. We don't necessarily need art that's inspired by nature, but it sure is nice to have around. We don't necessarily need parks and beautiful places to go visit. The Grand Canyon, the coast, or rivers to go rafting in and kayaking. We don't need these things, but they do contribute substantially to our enjoyment of life as they are part of our culture. So cultural services are not necessary to keep us alive, but they are important for our quality of life for cultures around the world. And of course, the last type of ecosystem service is the supporting services. These are those background processes that allow ecosystems to exist in the first place. Things like photosynthesis and soil formation. Without those kinds of things happening, you wouldn't even have the ecosystems to provide services for us. So I want to remind you that we have many scientific studies now that are showing us that ecosystems are providing more services and better quality services when they have their native species present and their populations are healthy. This is maybe the 3rd or 4th time that you've heard me talk about this. It is one of the most important concepts that I cover in this class, which is why you keep hearing this, and you'll hear it from me again in the future. We've also studied already some of the scientific theory behind why this is the case, why species diversity is so important to ecosystems. Remember that we learned about the study from the 1960s, the 1980s by Ehrlich's called the Rivet Hypothesis. It basically made the analogy that ecosystems are like airplanes, and the rivets are the little fasteners that hold parts of the airplane together. And if we lose a few rivets, sure, the plane can fly, but eventually you lose one more rivet, one too many, and the part of the plane falls off and the plane can have a crash. So all that to illustrate that species are like those rivets and that they're important for ecosystem function. You can lose a few and still get ecosystem function and ecosystem services, but if you lose too many, you're going to have a crash of the ecosystem and lose the majority of those ecosystem services. Now, that's been modified through time. In the more nuanced and more modern idea of this is the redundancy hypothesis. And it still uses the airplane as the model, and in this case where the ecosystem is the plane, the passengers and the humans that are on the plane are the different species. Some species are particularly important. That would be the pilot, the co-pilot, and the navigator. They're analogous to our keystone species that have a disproportionately large impact on shaping ecosystems. Remember, keystone species like the beaver is one example. The beaver, by making a dam on a stream, it creates an entire ecosystem, the pond ecosystem, where otherwise you would just have a stream. And so the beaver's impact is disproportionate to the numbers of beavers in the environment or their size, and so we call that a keystone species. So the pilot and co-pilot, they would be examples of like keystone species. As for the passengers, that would be like your more normal species in an ecosystem. And over evolutionary time, they come and go. Their populations rise, they fall, and so forth. Sometimes they're replaced by other species. Just like as a plane lands, you get new passengers come on and other passengers leave. All that to illustrate that there are some species that are particularly important to protect if you want to keep ecosystems around and healthy and you want to keep enjoying those ecosystem services. Those would be like your keystone species. But we also have to acknowledge that those passenger species, if you will, the little guys, so to speak, they are also important because they also help ensure ecosystem function, though their impact at a species level is not quite as large. Okay, with that review, we're ready to move on to our third part of this exploration of extinction and its consequences. We're going to look at the magnitude and the causes of the current extinction crisis.